All right, so this is called Visualizing Solids of Revolution. All right, and if you look on the side with the words, it explains to you what we're actually doing. I'm going to take you through those steps so you don't have to read it as you go. You don't have to flip back and forth. But it's there if you don't remember exactly what to do. But again, do not get ahead of me. All right, so we are going to first take these 4 points that are given to us in number 1, and we're going to plot these 4 points. This should be super easy, so go ahead and plot your 4 points. 0, 0, 0, 2, 4, 0, and 4, 2. Then after you plot those 4 points, use your ID badge because it's around your neck. It's easy to plop up on the table and use it as a straight edge to connect the 4 points to make your polygon. And when we do that, what is this polygon that we just, oh goodness, what is this polygon? A rectangle, okay? And we know that for sure because of the actual points, and we know things are perpendicular and whatnot, right? All right, so there's my polygon. Now what we're going to do, I know that you have done transformations before. You've done rotations, reflections, translations, dilations. That's not exactly what's happening here. We are changing things to a 3-dimensional type of situation. However, it is going to involve some of those transformations as well. So after you get your polygon, whatever it may be, in this case a rectangle, then we are going to shade it in. Okay, so you can shade it in lightly. I can't really shade lightly on this, so I'm just going to sort of shade mine in, but just if you're going to use the colored pencil, don't make it so dark you can't like see through it. Just shade it in lightly. It doesn't even have to be solid. You can just kind of scribble, but this will look better for you if I do this. This is an important step because otherwise you get confused as to what's what. Right? Now, what I want you to do, I want you to think without speaking. If I was to take this rectangle and it's telling me x-axis, and I'm going to revolve it around the x-axis, meaning that it's going to come, first of all, is the x-axis horizontal or vertical? Horizontal, okay. So I'm going to revolve it about the x-axis. So since it tells me that, I need to draw on here what the revolution is going to look like with a little arrow. So since this is my x-axis, my little arrow looks like this. That's an important step of what you're doing because you're saying, hey, that's how, so it's like a little curve to show that things are going to revolve. Make sure you put that around the correct axis. And then you actually do it with the same axis. Now, I just want you to visualize and think without speaking. If this rectangle is going to revolve around the x-axis, that means it's going to like come up off of your paper and it's going to revolve around 360 degrees until it matches back up with itself. So picture in your mind and just think without speaking what kind of figure you think that might create. Okay? All right. Everybody good? You ever have something in their mind and you can kind of visualize that? All right. Anybody want to tell me what they're thinking? A cylinder? Anybody got anything different? Is everybody thinking something? What do you think? Prism? What kind of prism? Rectangular prism? Okay. Anybody have anything else? A hexagon? Okay. All right. So anybody have anything different than those things? Okay. And so those are kind of the normal answers I usually get. Now, hexagon is a 2-dimensional figure, though, and we are going to get a 3-dimensional figure out of this. So do you think, well, like, did you really mean hexagon, or did you mean something? Like a hexagonal prism, maybe? Is that what you're thinking?
I was thinking the whole right, but I don't even know.
Okay, it's okay. All right, so here's the thing. When things revolve, if you have a revolution, what kind of motion does that imply? A circular motion, right? When things revolve, if you have a revolving restaurant, it's going in a circular manner, right? So that means when we revolve things, there are circles involved no matter what. So I get rectangular prism every time I ever ask that question about when the first time, because you haven't thought about these before. I don't expect everybody just to get it without me telling you anything else, but I just kind of want you to think about what's happening. Now here's what I want you to think about. You have a fresh jar of peanut butter, right? You took it off and you took off the lid and bam, fresh jar of peanut butter, right? Then you're going to take a table knife. You know what a table knife is? They're kind of rectangular, right? I mean, they kind of curve at the end, but they're kind of rectangular. Or a ruler. The ruler might be better to think about. Don't ever stick a ruler in your peanut butter, but we'll pretend. So you have one of these rulers. So you're just going to stick the ruler down inside the peanut butter, and you're going to turn the ruler 360 degrees. Then you're going to take it back out. And what kind of hole is in your peanut butter? A cylinder. Does that make sense? So that rectangle that revolved made a cylinder. You with me on that? Now here's the thing. If you're still thinking, oh my God, I never would have figured that out visually myself, that's okay. Because even people that get this right away aren't going to get some of these right away, or you think you do, and then that's not what it is. But I'm going to show you how to draw it, even if you have no clue what it's supposed to be. And that's the important part here, because you're going to get stranger and stranger things that aren't anything you can even describe. We're not going to get into the crazy ones that you can't describe, but when you get into the ones that aren't just polygons that are revolving, more in calculus, some of them either don't have names or they have names that you don't know yet, so you can't even hardly describe them. They're just like curves and stuff that are revolving. So right now, if you can visualize it, that's great. If you can't, that's okay. After you draw it, even if you don't know what you're drawing, then you can look at it and go, oh yeah, that's what it was. All right. So here are the steps. You draw it in, you draw your polygon, you shade it in. The next step is to take this and reflect it, not revolve, but reflect, which is a two-dimensional thing. Reflect it in the axis in which it says, so x-axis. If I'm going to take this and reflect it in the x-axis, then every point that's in my rectangle stays the same distance away on this side, right? So it's just going to look like this. Now you only have the original one shaded in. You don't shade in everything. Okay, so then we connect those dots where it kind of looks like one big rectangle, but it's really two rectangles, right? It's the original one, and then it is the reflected one. Thank you. Then you draw in, even though we know circles are involved, when you draw them two-dimensionally, do they look like circles? No, they look like ellipses. Now here's the key to this. Sometimes when you draw these things in, if your ellipses are too fat, they look too much like circles, it can make your picture look really weird, and then you can't even tell what it is. So here's a good rule of thumb. It's not really like the rule, but it works for pretty much everything. When I go to draw my ellipse, I am not going to make it go more than, okay, and here's what I mean by that. I'm going to take, so this point right here, reflected down to this point, right? This point didn't go anywhere. There's an infinite number of points on my rectangle. There are only 4 vertices. Those are my important ones. 2 of those vertices remain on the x-axis, so I don't even worry about them. I worry about the 2 vertices that actually move, and that's where my ellipses go. So I'm going to make an ellipse that goes from here to here, but I'm not going to go out farther than 1 unit like that. Does that make sense? And that doesn't look perfect. Let me try it again. Okay. Yeah, so go out about 1 unit. So that's kind of a good rule of thumb. If you go out a whole lot more, things just start to look very strange. And then on this one, I want to do some dotted stuff so I can kind of look like it's 3-dimensional a little bit better. So it can look like that. And then after you draw it in, now you should be able to see the cylinder, right? And you can do those steps even if you didn't know it was supposed to be a cylinder. Sometimes it's good not to even know, because then you don't draw it backwards, because sometimes like, oh, that's totally a cylinder, and then you draw it revolving the wrong way, that's a problem, okay? And if you need to turn your paper to look at it, you can turn your paper to look at it. We good? Any questions? All right, now let me show you this. Here's my rectangle, right? And it's sitting on the x-axis. And if I take this rectangle and I'm going to revolve it, the part that's left behind there, see how that makes the cylinder? Okay, that's what's happening. It's like these little things that, you know, you have Christmas bells or Easter eggs or whatever, those sort of things. But that's where your cylinder is coming from. That makes sense to you? It's kind of like thinking about either leaving something behind or maybe digging a hole, like however you, I mean, it's really a solid figure, so it's not really a hole like I said in the peanut butter, it's just a good visual. But, you know, if you were able to kind of draw 3-dimensionally, the stuff that would be left behind would be your cylinder. Okay, now let's go to number 3. And again, do not say anything. I know you get excited when you think you know what's going on, but you are ruining it for somebody that's still trying to process, okay? So we're going to plot our 3 points, 0, 0, 0, 3, 4, 0. And then we're going to connect those 3 dots with a straight edge. Okay? Then you're going to shade it in. Just lightly, just so it's, and it's fine, like you don't have to use color and stuff on your homework. I think it just helps if it's something different than your pencil sometimes. Shade that in. We are revolving about the x-axis again. So it's going to be kind of like that. Now, hang on. And then after you get all that, I want you to think without speaking about what 3-dimensional figure you would get when you revolve the triangle. about the x-axis. If I revolve it around different things, I would get different results, but on the x-axis. Okay, somebody. All right, let's go. All right, let's see.
I said it earlier. The cone. No.
A cone? All right, anybody have anything different than that? All right, so.
It's because I imagined it had like a stick of peanut butter.
Okay, that's good. And see, that's why I wanted you to have a weight. So if I put this in, here's my triangle, right? If I revolve it about the x-axis, there is the cone that I get. Now this one kind of kicks out a little bit, and I haven't been able to fix that, but because I can't actually buy these like I want, and I'm not talented enough to create them, so I had to buy other things and then cut them, and some of them just fell apart. But all right, so here's our steps to draw it correctly, because just because you know what it is doesn't mean it gets drawn correctly either. I have learned that big time. You still have to reflect it in that axis, which means this point comes here. Then you should know before you start drawing, regardless of whether or not you think you know what it's going to give you in the end, you have to think, how many key points are there? There are 3 vertices. Those are my important points. 2 of them remain attached to the axis of revolution, so they don't go anywhere. So only one of them moves, which means there's only one ellipse that you're going to draw. And so I'm going to draw it and not go out more than 1 unit, just so otherwise my cone looks really weird. And there you go. Everybody good? Any questions at all? All right. What do you mean? Well, we're going to tie this into surface area and volume, but then it ties into things are revolving all over the place in calculus for you to find areas of shapes that aren't like cones and stuff. There'll be curves, and you need the area under the curve to do the different things that you're doing. So this is really a calculus concept that we're beginning here anyway. All right, so number 5, we're going to plot the points 0, 0, 2, 4, and 6, 0. Now I want you to think without speaking about what you might get when you revolve it about the x-axis. Okay, but I'm not going to ask you to tell me this time. I want you to think about what you, just see if you can visualize it before you actually do it, all right? And then I want you to go ahead and draw it. Even if you don't know what you're supposed to get, follow the steps that I gave you and see if you can get it drawn. And you should be working with pencil, because using your pencil and then not a pen in case it doesn't come out right. And then the colored pencils are erasable too. But I mean, hopefully the colored pencil part isn't wrong. Just give you a second to get that drawn. Think about, do the reflection. Think about how many ellipses you're going to have. All that good kind of stuff. Oops, sorry. So remember, once you draw it in and you color it, then you should be drawing and not just sitting there like some of you are. Make sure your original one is it shaded in? I don't have my glasses on. Reflect it, draw it, keep going. Is your original colored in? It's just red light. That's fine. It's fine that it is. Reflect it. Think about which of the vertices actually have some motion going with them. Draw in that ellipse. It's okay, even as you're drawing in the ellipse, and even after you're done, if you're still like, I don't even know what the heck this is, you could still possibly have a correct picture. I'm going to get the rest of mine drawn in. Okay, so remember, I reflect it Yes? So I've reflected in the x-axis. Make sure you're doing it in the correct axis and all that good kind of stuff. And then I have 3 vertices because it was a triangle. How many of the vertices are actually creating a motion for me? 1. So you have 1 ellipse, and there should be no question as to where it goes. This point, even when it reflected down here, but it's going to come here, it's going to come off the board and revolve around back right there. So there's an ellipse that goes from this point to this point, and so it would look something like this, and it's okay if yours was dotted differently or whatever. Okay? So, if I hear people whispering about what it is, and that just makes my skin crawl. Everybody needs a chance to process through on their own. Please do not say anything until I have asked you to. You may not think it's a big deal, but it is, because some of this stuff is really, really hard for some people. Okay, so we've got this. Now, was there anybody that before you drew it, you're like, I really have no idea what that is, or you thought you did, but now you've changed your mind, or now you can kind of see it? Anybody couldn't see it, now you can? Okay, good. Anybody thought they knew what it was, but now you think it's something different? Just curious. Okay. So, Alyssa, tell me, can you describe to me what this is? 2 cones put together. Okay, good. Do y'all agree with that? 2 cones that share the same base, right? And could you give me like a real world example if you couldn't come up with something like, what does this remind you of maybe? Like a spinner top, like a top. Okay, if you turned it sideways, it'd be like a top. That would work. Now, what can help is if you can realize, you know that you have your ellipse. If you plot the center point of the ellipse, then that can kind of help you maybe separate some things sometimes. So if this is my ellipse, the center would be that point right there, and then that kind of helps you separate it into 2 cones a little bit better visually maybe. And again, you didn't have to know that that's where it was, but that will help you understand the height and the radius and all that stuff a little bit better when you go back and look at the pictures. So here is an example of that. It's a little bit longer, but it's the best I could do. So I'm sitting on the x-axis. This comes around and revolves, and then this is what you get, like 2 cones that are put together. Which in this case, are these 2 cones congruent? No, they could be, but these are not, right? We all good with that? Okay. So now, let's go, we're going to go to number 6. So number 6, it's the same 3 points to begin with. We'll plot this point, and then 2, 4, and then 6, 0. And then we're going to connect those. Now, the difference between 5 and 6 is that on 5, we revolved it around the x-axis. Now we are going to revolve it around about the y-axis. And so it is going to revolve like so, 360 degrees. Or really, the other way, I guess, is better. Really going this way. Comes off the board and goes back there. Now, all I want drawn on your paper right now is that. That's it. Okay? And then I want you to think without speaking, which includes whispering or hand motions or anything else to anybody else. Think without speaking about what you might get when you revolve it. And if you're not sure, at least think about how it might be different and those kinds of things. See if you can kind of get a picture in your head of what's happening. Right? And then have some sort of idea in your head. You don't have to tell me, just think of it. And then I want you to go ahead and take this and draw it. Do the same thing. Reflect it, get any ellipses in there, and then see if you can have a better idea of what it is. And I'm going to give you a minute to work on that. Okay? Process is the same every single time. Think about it, then if you don't know, that's fine. You may not be right anyway, and then because it can get confusing. Reflect it. Think about which vertices are creating the motion. Make sure you do the ellipses with the correct ones. So I first reflect it, right? Bam, there's my reflection. Then you can't let the fact that you're already thinking, what the heck is this? Don't let that can't stump you at all. It doesn't even matter at this point, really. I mean, if you can see it, that's great. I do want you to try and visualize it, but it's fine if you're still like, I have no idea what this is. Remember, your axis of revolution is the y-axis. So this point stays here. This point revolves, but it does not revolve to here. I don't think I saw that on anybody's, but I see that a lot where people try and draw an ellipse here. That would mean your axis of revolution is in here, and that's not what's happening. This point actually revolves all the way around to this one. Do you agree with that? So my ellipse goes between these two, so it will look something like this here. Okay? Everybody okay with that? And then this point right here, it moves too. It revolves around to here. So I need an ellipse here as well, which that one doesn't actually have to have anything dotted because it's like the top, but it's fine. A lot of you had dotted, and that's okay, but really it's kind of a solid thing. You put the dotted when it's like behind and you technically wouldn't be able to see it, right? I should be able to see that if it's the top. So that's what I end up with, okay? Now, who wants to describe to me what it is? Go ahead. Okay, and that's it? Go ahead. You're very, very excited today. Go ahead.
It's like the cone's on inside the cone.
Okay.
Like it's inverted.
Okay. Kind of, yes. No, they're kind of both right together. Aiden?
I kind of imagine like the whole thing with one big cone.
Okay.
The top is cut off and it's like kind of down.
Okay, so another cone goes down in it. So they're kind of the two of them together is kind of what Aiden said. What do you think? It is. Yes, and so the cone in the middle is hollow. That's why you want to shade the original, because that's where the solid part actually is. That's the part that's doing the revolution, that's actually creating a three. And I don't have one of these to show you because, like I said, I'm not talented enough to actually create one of these myself. I did have a student create one for me, but that was years ago, and I should have had maybe some more. But I didn't know. I couldn't figure out how to do that without making it all fall apart. But anyway, this is what's revolving. You can kind of visualize it, because maybe if I had an inflatable cone, then I could take the vertex and push it down inside of there. What that would mean then is that the part of the cone that is missing off of the top and the part of the cone that's turned around down inside would be the same, right? If I just physically inverted it. But that's not what's happening here. The part that got cut off on this specific one, the top gets chopped off, and then there's a cone that's like turned around and stuck down inside, upside down. Those two cones are actually different sizes, okay? But it is still kind of that idea if you want to visualize it. So give me like a real world example of what this might be able to look like. Okay, like a dog cone, yes. A volcano? I think a volcano is a good one too, right? Because a volcano, and kind of like a funnel, yeah, some funnels, right? So a volcano, kind of comes up, but it's not really a cone, but maybe if we kept going, we could make a cone, and then you got stuff down inside of it, and that's what's happening here, right? After you draw it, you have to be able to visualize some of that stuff, because you're still going to have to find things like height and radius and all that good kind of stuff. And if you don't even know what you're looking at, you don't know what you're looking for. Now, is it going to be pretty easy to find the radius of these things and the height? Like, it's not that bad. It's graphed. It's really not that big of a deal. But if you have no clue what you're looking at, then you don't even know what you're looking for. Does that make sense to you? We good? Any questions? All right. So I want to show you something else. You can flip this over on the other side. You can draw some of these that I'm going to give you. There's not, because you're going to need the other room on the other side, but if I give you this, I'm going to give you something, and I want you to think about it, and I want you you can draw it, but again, I want you to think without speaking, and since we don't actually have a grid to do it on, mine definitely won't be as neat and pretty as it should be, but I will try to do my best here. Okay, so if I draw this in, first of all, what is this shape that I'm intending to draw here? Trapezoid. Okay, good. So this is a trapezoid. And if I take this trapezoid, I could revolve it a few different ways. Let's say I'm going to revolve this one about the x-axis. So see if you can think of what it would look like before you even did that, before you even did anything. And then you can go ahead and try and get it drawn. And you kind of have to guess at the, like, and since you don't have coordinates here, you have to kind of just eyeball it and get it as congruent as possible, because the two figures should be congruent to each other. It looks something sort of like this. How many ellipses am I going to have? 2. So it would look something like this. Now, who can give me the real name for this and not just a description of this? We've talked about it a couple of times, and I used the word with you, but it starts with a T. I don't know if it's actually, I see you going, I don't know that it's actually in your notes. I don't know if it's written down or not, but because I think that you could describe this to me. Could you describe it? I don't want you to, but could you describe to me what it is? And sometimes it helps maybe to turn your paper, but I want the real word for it. It starts with a T. Actually, it is in your notes. Truncated cone. Thank you. It is in your notes. Okay. I just remember that now. It is in that one. It's a truncated cone. It's like a cone with its head chopped off, right? And it's sideways. And what this makes me think of is like if I turned my paper, it was actually even because mine's clearly not perfect. The things that the elephants put their foot on at the circus, like the little stand, because it's like a little truncated cone is what that is, right? So what if I did it like this then? And you don't necessarily have to draw this one. I just want to see if you can think about it, and I'll draw it in quickly. So if I did the same thing, but this time I revolved it about the y-axis. Let's try to do it quickly here. If I revolved it around the y-axis instead. So here, let me show you the first one. Make sure I have the right thing here. No. I have all these different ones. There we go. So this is the truncated cone. Looks like this. And so literally, I think this was a cone, and then I chopped the top off of it. That's like literally how I made that. All right. Who can describe to me the next one? I may not have it here. Anybody but Omar? Omar's got this down. Yeah, can you describe that to me? How would you describe what you would get? Okay. Oh, dang it, he was right. Yes. Okay, good. And I thought I had an example of that over here. Apparently I don't. I didn't pull it out anyway. No, I can't. It doesn't open the other way. I can only open it one way. I have one in here somewhere. I thought I did. Here it is. I think it's a little bit of a taller one. Here it is. It's a taller one, but you see this trapezoid, and then bam, you get a cylinder with a cone on top of it, right? What if I revolved it instead of around about the y-axis, about whatever this line is right here? Oh, here's the one I was looking for. I'd have an inverted cone, so that's a good one. That's good. I dropped all these. Now we can't find them. Here you go. So it would look like this, except that one in particular would go like all the way down there. But you see how it's like a cylinder with a cone inverted in it? See that? And if you drew it, you'd be able to see it better. I just don't want you to have to necessarily draw them all. All right. Now, the other thing I want you to understand is we're going from 2-dimensional axes to 3-dimensional axis. Okay, and you don't necessarily have to draw this, but this is what's happening. You have an X, Y, and now we also have a Z axis. So when we graph the stuff 2-dimensionally, we're graphing it on the X and Y axis, and then when we're evolving it, we're bringing it out and having it go through the Z axis. So when you start to plot points 3-dimensionally, instead of having an X and a Y coordinate, you have an X, Y, and a Z. So you know how far left, right, and how far out it comes. That's your third dimension there. Okay, does that make sense to you? Now this one, if I take this, and I revolve this about the x-axis, what do you think I'm going to get? A sphere, okay? So if I revolve this, I'm going to get a sphere. Now this is the one many years ago, a student made this for me, and so I know it's possible. And I've tried to, this is called Honeycomb Paper, and I've tried to Google stuff, even on Pinterest, but anytime you Google anything with honeycomb, you get honeycombs. I don't want anything to do with bees. So I know I can buy the paper, but I can't create some of these. I'm just not talented enough. I've tried to get you some more little visuals, but that's the best I can do on those, I think. All right, so do you get the general idea here? It's important that you understand the basic ones because things are going to get more complicated pretty quickly, but it's not really that complicated. Like it's something that's totally doable for you as long as you don't freak out in the middle of it. Right, so let's go back and talk about what the rest of what you need to do. So we've done 4 of these together, which means you only have 2 that you have to go back and actually graph on your own correctly. After they're all plotted and drawn, then you go back and you find the surface area and volume of each one, okay? It's really easy. Let's look up here. On this right here, what is the radius of this cylinder? The height? 4. Do you need anything more than that to find surface area and volume? No, it's not as bad as you think, okay? Now, I will tell you on number 6, be very careful about what you're doing and think about how you actually know the height of the original cone. Don't be making stuff up. Think mathematically about how you know, and some of the numbers on that one come out a little weird. So you'll have some square roots that make you, they really don't make you that uncomfortable anymore. Just know that it doesn't come out real pretty, so I don't want you to think you're doing it wrong since I don't really see you tomorrow, okay? Are we good? You can do this. It's not outrageous, I promise. All right, any questions? Yeah, you're going to have to graph 2 and 4 on your own, and then every single one of them, you find the surface area and the volume, and you really should have enough room for all of them. Number 6 might require, number 6 might require you a little bit more room, but you could use the back of that if you needed to. Okay, we good? Any questions? Awesome. All right, so go ahead and try and get the rest of them drawn before you leave so I can check them.